With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there is a wedge which is moving rightward on which there is a block of 10 kg is placed on it. Now the friction coefficient between the wedge and the block is 0.8 and we need to check the correct alternative. Now the first option is if wedge is moving with a constant velocity, friction force acting on the block is 64 Newton. We need to check this. Now we know that what is the, if we just draw the FBD for this part, we can say that there would be this weight which would be acting downward, and we also already know that the component of weight in the direction of the incline would be equals to mg sine theta. The normal force would be in this direction, and the component of the weight perpendicular to the we can say that our wedge, or we can say that our incline, it would be equals to mg cos of theta. Okay, now these are the cases. Now from this expression we can get what is the maximum value of the friction force. It would be equals to mu into n. This is the limiting force of this friction value. So mu value is given as to be 0.8. Now what would be the normal reaction? We can see that from the vertical equilibrium, this vertical to the incline, we can say that n would be equals to mg cos of theta. Now mg is 10, m is 10, g is 10 into cos 37. Cos 37 would be equals to, because this angle is 37, this is our theta. So this would be equals to cos 37, 4 divided by 5. So we can say that this would be equals to 64 Newton. Okay, this would be equals to 64 Newton. Now what is this for? Mg sine theta. Now if we calculate our mg sine theta, so mg, so what is our mg? So we say that this is mass would be equals to 10, g would be 10, and sine 37 is 3 divided by 5. Now this would turn out to be 60 Newton. That means when this object, because it is moving with a constant velocity, there won't be any pseudo force. So these are the only forces which are acting. So we can say that this mg sine theta is less than our maximum value of the friction. That means what is the value of the friction force in this situation? It would be just 60 Newton and not 64 Newton. Okay, it would be the value of the F max, or we can say that this friction force would be equals to mg sine theta. So A option is wrong and B option is correct, because here it is given that if the wedge is moving with constant velocity, acceleration of the block is 0. Okay, so we can say that this option is right. Why? Because friction force would be 60 Newton and this mg sine theta is also 60 Newton. So friction force is acting in this direction, mg sine theta is acting in the downward direction, net force is 0, therefore net acceleration would be 0. Now in the C part, it is given that if the wedge is moving with some acceleration to I cap, then the friction force on the block is 44 Newton. Now we just draw the FBD for our block. So we have already seen that this is our mg sine theta, and this would be our if it is moving, we can say that we need to just figure out, first of all, we just write our pseudo force. So pseudo force would be acting in the backward direction because it is moving in the I cap. So pseudo force would be acting in the opposite direction. Now we just say that this is our mg sine theta, which value is 60 Newton. Now what is the pseudo force? F pseudo, this is equals to mass of the block into our acceleration. Mass of the block is given as to be 10 and acceleration is 2. So it would be 10 into 2. That means this would be equals to 20 Newton. So this is about 20 Newton. Now this angle would be equals to what? It would be the angle of the incline, 37 degrees. So the component of 20 Newton along this direction, it would be 20 sine of 37, cos of 37, because this angle is 37. So this would be cos 37. Now if you put the value of cos 37 as 4 by 5, then this value 20 into 4 by 5, this would turn out to be 16 Newton. Now if we just balance this, so friction force, because this force is greater, okay, so friction force would try to oppose this force. So it would be acting in the upward direction. So we can say that 60 would be equals to F plus 16. Now from this expression, we can get our friction force value would be equals to 44 Newton. And this is less than the maximum value. So we can say that this would be the correct part. So C is the correct option. Now in the D case, acceleration is increased to 10 meter per second square. So what would be the new pseudo force? New pseudo force would be equals to m into a, so it would be 10 into 10. This would be equals to 100 Newton. Now again, if we just draw our FBD, so this is our mg sine theta, which is 60. Now this is our pseudo force acting in the backward direction, opposite to the acceleration, and we can just take its component into this direction along the incline to get the value of the friction force. This angle would be 37. This is, we have calculated 100. So this would be 100 cos of 37. So cos 37 is 4 by 5. If we put the value as cos 37 to be 4 by 5 and multiplied by 100, this would turn out to be 80. And what is this? This is our mg sine theta, which we have already calculated to be 60 Newton. Now, in this situation, we can see that upward force is greater than the downward force. That means frictional force would be acting in the downward direction. So it would be 80 equals to F plus 60. That means frictional force value would be equals to 20 Newton. Now, this value is again less than the this maximum friction value. So we can say that this is our okay situation. So friction force 20 Newton acting downward. So D is also the correct option. So B, C, and D are the correct options. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.